When we talk about circuit reliability, one of the key concepts that is routinely highlighted is that of a leakage current. We hear how contamination and residues on the surface of our boards can cause these leakage currents that, in the best case, just temporarily alter the functionality of the board, but normally can cause significant and permanent damage. If you've ever wondered what we mean by a leakage current and what's actually happening on the board, stick around, because today we're going to be diving into the world of electrochemistry to discover why we need to take so much care to clean our high reliability products. Let's start our discussion of leakage currents by first considering our test vehicle. In many cases, we use surface insulation resistance, or SIR, measurements to determine the quality of a cleaning process. Let's take a look at one of those SIR patterns to see what's going on. If we examine them closely, we see that the pattern consists of a series of interdigitated traces, where every other trace is connected. We essentially have two overlapping combs that form the pattern. We apply a voltage across the pattern, say 5 volts, and measure the resistance across the pattern. Now, there isn't actually a resistor present, but the concept is that the space between the traces, which could be FR4, air, or even residues on the surface, can act to transfer current across those patterns, in essence, an effective resistor. In reality, what our meter is measuring is the current that is flowing across the gap and using Ohm's law to convert that to a resistance. But if there's no actual resistor, how is current flowing? Well, this is the leakage current we talk about. It's not a part of the schematic and can significantly affect how the circuit functions. In this example, it's just a test coupon and there is no active circuitry on board, but imagine you have sensitive measurement or RF circuits. Any small leaks or interference could render the circuit useless. So what's actually happening on the surface of the board? Well, if we could zoom in on those surfaces, we would see a plethora of chemical reactions happening at the surface. We call them redox or reduction-oxidation reactions because they involve reducing and oxidizing something on the surface, which ends up transferring electrons. This transfer of electrons from those chemical reactions is what we end up calling a leakage current. Even though the electrons are not traversing the gap, the ionic contamination is. This can exacerbate phenomena like electrochemical migration, where the actual metal itself is oxidized and reduced, leading to dendrite formation. In summary, a leakage current is no more than a bunch of chemical reactions happening at the surface of the trace, which cause a real and very measurable current to flow. Cleaning your boards can significantly reduce this by removing the ionic contamination that can contribute to these currents. Thanks so much for watching. If you enjoyed this video, don't forget to give it a thumbs up and let me know your thoughts or questions in the comments below. You can also email questions or comments to AskDrAdam@Kyzen.com. If you're new here, make sure to hit that subscribe button and turn on the notification bell so you don't miss any new episodes. And as always, stay clean.